Okay, I am recording. Good evening. My name is Sally Lipsky, and I'm leader for Plant-Based Pittsburgh. I'm delighted to see so many new people. Everybody is going to get an email from me tomorrow, which will have a link to the recording to tonight's event. And also it will be in our Plant-Based Pittsburgh YouTube channel, and anything that comes up during the event as a follow-up will be in the email. And you'll also get your code for 25% off of the no cheese nacho cheese dip from the Happy Vegan. So I am delighted to introduce Dr. Sandra Sobel, who I just met recently, but it's such a thrilling to have a plant-based endocrinologist, at least one, I see more here, in the Pittsburgh area. So Dr. Sobel is board certified internal medicine, diabetes, endocrinology, metabolism, and lifestyle medicine. That isn't enough. She's also a clinical assistant professor of medicine at the Department of Endocrinology at University of Pittsburgh Medical Center and clinical chief endocrinology at Mercy Hospital, University of Pittsburgh Medical Center. So without further ado, welcome, Dr. Sobel. The floor is yours.
Thank you. Thank you so much. And thank you everyone for being here this evening and taking some time. It was so nice to see some familiar names in the chat. So I really, really appreciate all your attention. And I can see myself. I'm not a cat emoji on Zoom. So already starting to talk off on a bang. So the title of my talk is Plant Powered, Activating Metabolism to Reduce and Reverse Obesity and Diabetes. And there we go. Okay. So whenever I just want to acknowledge that whenever we're thinking about, major goals that we have for ourselves, oftentimes there are several paths that lead to a common goal. And the goal that I'm going to be discussing this evening is that of improved and lasting health. And specifically, when we think about nutrition approaches for improved and lasting health, there are a whole slew of different nutrition approaches that we can take. And the one that I'll be focusing on is plant-based nutrition. And so some of you might be already whole food plant-based enthusiasts, whereas some of you might just be more plant curious. But I hope that, toward the end of this and throughout the talk, you'll be able to just gather some information and see just the support, the medical support that there is for a plant-based approach when it comes to specifically addressing obesity and diabetes. And so when I discuss plant-based nutrition in the clinic with patients, I will say that frequently a lot of individuals are really excited and curious to learn more. Also, there's a significant proportion of individuals who look at me with this like glazed over look, like, what are you talking about? And what I found is that it's probably born out of some misperceptions. So as an example, for those of you who have never been to Pittsburgh, you might think that Pittsburgh looks something like this. And full disclosure, I'm not from Pittsburgh. And I did think that this might be something that I was coming to. So we are known as a steel city. You might think that there's still steel mills with smoke pouring out of the smokestacks. But I've been living here for 10 years now. And I can definitely say that this is actually what Pittsburgh, Pennsylvania looks like. It's a gorgeous city surrounded by 3 rivers, beautiful hills, and a really magnificent downtown area. And so similarly, when individuals are thinking of plant-based eating, they might be thinking that they need to eat like a bird and are then having to eat seeds for the rest of their life. In fact, plant-based eating is delicious, and it has a significant variety of different types of food, and with important nutrients, all that are important for our health. And so almost 2,500 years ago, Hippocrates said, just as food causes chronic disease, it can be the most powerful cure. And certainly that sentiment, that thought, still holds true today. So here are the objectives of my talk. I hope to demonstrate influences impacting hormones, obesity, and diabetes. I hope to define total energy expenditure and obesity, discuss statistics related to obesity in the United States, also define diabetes and discuss statistics related to diabetes in the United States and the standard of care, review some nutrition approaches, such as the standard American diet, as well as others, review plant-based nutrition, and then I will bring in some medical literature and share some studies with you guys on how plant-based nutrition and lifestyle medicine can reduce or reverse obesity and diabetes. All right, so this is a busy slide, but the purpose of this slide is just to show you how much of an impact our lifestyle can have on our hormones and obesity and diabetes. And so this slide is actually taken from Dr. Jeffrey Seek at his presentation at the Obesity Medicine Association conference. And what I want to highlight with this slide is just to show you how certain aspects of our life can really impact our predisposition to obesity and diabetes. So if we start at the top, we see how lifestyle, depression, and stress can affect something like sleep. And sleep, just being one important aspect, can lead to dysregulation of several hormones. And depending on what these hormones do, that can affect our appetite, that can affect our energy expenditure, that can affect our insulin resistance. And all of these go on to affect our predisposition to diabetes, as well as obesity. And like a good hormonal system, this all feeds back on itself. And this is a dynamic process that continues. So let's talk about metabolism. What is it? How do we define it? So metabolism is akin to total energy expenditure. So it's the way that our bodies are able to convert what we eat, what we drink, and use it to make and release energy. And it's important to also realize that resting requires energy as well. So simple functions such as breathing, such as blood circulation, such as cell repair, cell growth, all of that requires energy. And so that type of energy is known as resting energy expenditure. So what you see here is, so total daily energy expenditure is made up of three major components. So resting energy expenditure is the major component of this. There's also non-resting energy expenditure. And I'll go into this in more detail later, but essentially what this is referring to is physical activity. And you can see the component that this makes of our total energy expenditure per day, about 30 to 40%. And the last is something called thermogenic effect of food. What is that? That's the amount of energy our body requires to digest food, to absorb food, to transport and store food. And that can make up anywhere between 5 to 10% of our daily energy expenditure. Okay, so let's define obesity. So as per the Obesity Medicine Association, the definition is chronic, relapsing, multifactorial, neurobehavioral disease, wherein an increase in body fat promotes adipose tissue dysfunction and abnormal fat mass physical forces, resulting in adverse metabolic, biomechanical, and psychosocial health consequences. That's a really long definition. But I want to draw your attention to some important things. Number one, in that definition, you don't see any threshold of BMI. You don't see any threshold of percent body fat mass, okay? We do use those markers to help quantify adiposity. But really what it's important to realize is obesity, number one, is a medical condition in and of itself. And what we're talking about specifically is when fat is dysfunctional, okay? When it's causing adverse health consequences, either directly because of how it functions or even the mass and the mass effect that that can have on our body. So let's go through some statistics. And here in this graph, what I want to demonstrate is just the prevalence of diabetes and how that's changed over the years. So if we start at the bottom, this was the prevalence of diabetes in 1999 to 2000, which was about 30%. And then more recently, into 2018, the prevalence rose from 30% to 42%. In the same time frame windows, if we compare severe obesity, which is defined as a BMI of greater than 40 kilograms per meter squared, that prevalence almost doubled to 9.2%. And what's really unfortunate is that obesity is expensive. The estimated annual cost of obesity is $147 billion. Individuals with obesity spend $1,400 more per year in medical costs compared with those who have normal weight. And so there are different types of obesity. Typically, when we think of obesity or adiposity, we think of subcutaneous fat accumulation. And especially in the abdominal area, this subcutaneous fat accumulation is that's underneath the skin, above the abdominal muscles. Whenever those fat stores are exceeded, there's excess energy that's circulating, then the body needs to look for areas to store it other than the subcutaneous fat. And so where it starts to store is here in the viscera. So that is the area of the body below the abdominal muscles where a lot of our essential organs are housed. And in fact, this fat can start to infiltrate organs such as the liver, such as the pancreas, causing significant adverse health consequences. And in fact, this visceral fat is notorious for being this particular type of dysfunctional fat that is highly correlated with metabolic disease and cardiovascular disease. And here you can see listed a variety of different obesity-related health conditions, such as certain types of cancer, heart disease, stroke, and type 2 diabetes. So let's define diabetes. So in a healthy pancreas, a healthy functioning pancreas, the pancreas makes a variety of hormones. One of the important hormones it makes is insulin. And so insulin, what it does is it attaches to an insulin receptor of a cell. And when the insulin attaches to a receptor in a cell, that leads to a variety of intracellular signals, which eventually results in glucose, which is in the circulation, making its way into the cell. And then the cell can use the glucose as its energy in order to perform the functions that it needs to perform. Now, there are a lot of different categorizations of diabetes. I'm just going to mention the two that we commonly think of. So there's type 1 diabetes. So type 1 diabetes is an autoimmune condition. And so what happens in type 1 diabetes is that the body attacks its own insulin producing cells. And when it attacks the insulin producing cells, the pancreas can no longer make enough insulin. And as you recall, insulin is the hormone that's important to keep blood sugar levels in check. If you have no insulin, then you don't have anything that attaches to the receptor. The cell is unable to allow glucose to come inside. And so the glucose stays outside of the cell. It's extracellular. It stays in the circulation. And as this accumulates, blood sugars continue to rise. Individuals begin to show signs of diabetes, which can include increased thirst, increased urination, maybe even blurry vision. And so because the pancreas is no longer able to make insulin, the only way we can treat it is by giving insulin therapy. So if we contrast this with type 2 diabetes, it has a different method by which it presents. And so typically it's associated with excess calories. And with the excess calories, there's an increase in adiposity. And this increased adiposity leads to dysfunction of the adipose tissue. The adipose tissue is actually a highly active endocrine organ. We used to think that adipose tissue was inert, but what we found is that it secretes many different hormones, many different inflammatory markers. And so if there's an increase in this dysfunctional adiposity, it results in overall inflammation. And why can this be harmful? Unfortunately, inflammation leads to damage of the insulin producing cells, but it also can lead to damage of the insulin receptor. And so if you get a combination of both, this often leads to what we call insulin resistance. And so the pancreas tries to compensate. It senses that there's still a lot of glucose circulating, so it's still trying to put out more insulin. And for a while, it's able to keep up, but it needs to give more insulin. And that's why we can sometimes see that insulin levels are higher before blood sugars really begin to appear to be above the goal. But eventually the pancreas can't keep up. And when the pancreas can't keep up anymore, because it still can't make enough insulin for the amount of sugar that there is, or it can't make enough good quality insulin, blood sugars keep rising. Glucose levels are so high that, again, people become symptomatic, and this results in diabetes. And so I want to draw your attention to this term called an A1C, because you're going to hear me talk about it later on in the talk as well. What the A1C is a blood test that health providers will use as one of the ways that we measure diabetes control. In general, individuals will have very specific A1C targets. But in a population, we recognize that getting an A1C of 7% or lower helps prevent adverse health consequences to small vessels that supply the eyes, the kidneys, and nerve endings, as well as keeping it below 7% helps prevent large vessel disease, the vessels that supply our heart, our brain, and vessels to our legs. And so typically this is the goal that we aim for, to keep the blood sugars in that range. So what are some of the statistics associated with diabetes? So just over 4,000 Americans are diagnosed with type 2 diabetes daily, and 356 of these individuals will undergo amputation, and almost 160 will undergo treatment for end-stage kidney disease. And the costs of diabetes are staggering. So the annual cost of diabetes is $327 billion, 237 billion, which are in direct medical costs, and 90 billion in indirect costs, which manifests as absenteeism, reduced productivity, and disability. And if we look at what the medical costs for diabetes were in 2012 and compare it to what they were in 2017, just in those 5 years, there was a 26% cost increase for diabetes. Individuals who have diabetes are at 2.3 times greater healthcare costs, incur greater healthcare costs than those who don't have diabetes. And so the diabetes that I'll be referring to for the remainder of the talk is primarily type 2 diabetes. So what's present day diabetes management? So I'm sharing with you a screenshot of our treatment algorithm. So many of us who are in the healthcare profession that help individuals who have diabetes are familiar with this algorithm. And this is taken from our prominent diabetes journal and is very helpful in identifying where individuals are with their diabetes control, what other medical conditions they might have. And we sort of follow this to see what medications are appropriate and safe and maybe of most benefit to our patients. And as you can see, it's quite a busy slide. As a physician, I'm very grateful for the science behind the development of medications. I recognize the utility of these medications and the importance that they have in helping our patients with type 2 diabetes get their blood sugars to goal. I also recognize that these medications are definitely helping control their disease, but at the same time, we're asking our patients to accept the risk of side effects associated with the medications. We're asking the patients to accept the risks of these medications interacting with other medications that they might be on. And they still have the disease, right? They still have potentially risk of developing this small vessel disease and large vessel disease. And so what's important to see here, and it's in teeny tiny lettering at the very top, but it is first line therapy. In addition to metformin, which is a medication, is comprehensive lifestyle changes. The importance of weight management, the importance of physical activity, and nutrition is part of that as well. And so if we can help our patients by addressing a potential source of this disease, we can help potentially reduce the burden of medical costs, their medications, and even improve their health overall. So Maimonides was a famous philosopher and physician, and he stated that no disease that can be treated by diet should be treated with any other means. Now, that's a pretty bold statement. And again, I'm very grateful for the medications that we have available, and I do use them often with my patients. I also think that it's important that we have conversations in our office and in an interdisciplinary team about the importance of lifestyle and how that impacts disease. So, what are the nutrition approaches? This slide defines what processed food means, because we hear that a lot, but what exactly does that mean? So unprocessed food or minimally processed food refers to foods that are mostly unaltered. They're in their original form. So think a banana, think green peppers, food like that. Processed food has had some alteration, has had something done to it, whether it's with cooking or freezing or packaging, like in canned foods. And in some of these foods, flavors have been added, sugar, salt, or fat. Enhances the flavor and actually makes us want to eat more. There are some processed foods, though, that some people consider healthful. And some of those examples can include olive oil or dark chocolate. And then there's ultra processed foods. And these are alteration, these have been altered a lot. Sorry, I'm just trying to move I just figured out how to minimize the video window. So ultra processed foods, they've had a significant alteration in their food structure. They are very calorie dense, and they've had a lot of enhancement to their taste. And the issue with this is that they can also, because of these alterations, are more readily absorbed by our gastrointestinal tract. And these calories come flooding into our system. And so some examples of ultra-processed food include white breads, sweetened cereals, instant noodles, candy, and sweetened beverages. So, segue to the standard American diet. So 63% of the standard American diet is composed of highly processed foods. And these are foods that have added fats, oils, sugars, refined grains. It's a diet that's high in saturated and hydrogenated fats, such as French fries, such as microwave popcorn, and such as potato chips. 25% of the diet is composed of animal fats and proteins, so meat, dairies, and so forth. And unfortunately, it's a diet that's low in fiber, low in complex carbohydrates, low in fruits and vegetables. It's said that 12%, on average, 12% of the standard American diet comes from a plant source. But if you really dig into that statistic, only 6% are the unprocessed vegetables, these whole fruits, legumes, grains, nuts. Whereas the other 6% are processed plant foods like almonds and candy, apples and apple pie, tomato and pizza sauce. So kind of crazy. If we look at the United States nutrition habits or even lifestyle habits over the past 100 years, it can be quite shocking. So in this graph here on the right, this is demonstrating sugar consumption in kilogram per individual on the y-axis. And here on this x-axis, you can see the year. These black diamonds are US individuals. The white ones are from the UK. And so what you can see here is, around the 1960s, 1970s, the amount of sugar consumption in kilogram per individual per year was about 55 kilograms per individual. And in 2000 was about 70 kilograms per individual. What does that mean in pounds? It's greater than 140 pounds of sugar per year per individual, contrasted to less than 10 pounds in the turn of the 20th century. Oil intake has increased from 4 pounds to 70 pounds. Cheese intake had increased by 25 pounds. And then television increased from watching 0 hours per day in the 1900s to about 4 hours per day in 2000. So what are some alternatives to the standard American diet? And so there are, as I mentioned, several different nutrition plans. And so I think it's important to identify them and talk about them to know what's out there and educate ourselves. So one approach is the low carbohydrate diet. And what that means is trying to keep carbohydrates between 50 and 150 grams of carbohydrate per day. And some will even say less than 100 grams per day. And so if we're looking at a 2,000 calorie per day diet, what this means is that carbohydrates make up 10 to 30% of the total calories in the diet. Now, the very low carb or ketogenic diet, that usually starts at less than 20 grams of carbohydrate per day. And individuals will follow this for several weeks and slowly add back carbohydrate. And in the maintenance phase, they still don't exceed more than 90 grams of carbohydrate per day. And so here in this picture, you see an example of some of the foods that individuals might pull from a ketogenic diet. And as you can see here, it is a very high fat diet. Another nutrition approach includes the Mediterranean diet. And so here's a pictorial of a food pyramid that composes the Mediterranean diet. And what you can see here is actually at the base of the Mediterranean diet, we see whole grains, fruits, vegetables. Olive oil is an integral part of the diet, and it's used in preparation of foods. Seafood also is a good component of the Mediterranean lifestyle for its omega-3s. And then a smaller proportion is poultry and dairy. And the dairy is more of a fermented dairy that they refer to, such as in Greek yogurt. And you can see the minority comes from meats and sweets. Wine in moderation with certain meals, and some water. Now let's talk about restricted fat variants. Okay, so when we talked about the low carb diet, I mentioned how the low carb diet pulls 10 to 30% of its total calories from carbohydrate. Contrast this to a low fat, where 10 to 30% of total calories come from fat. So if we're talking about, again, a 2,000 calorie per day diet, that means in a day, no more than 66 grams of fat in the diet. What we found, if you'll recall, in the late 1980s, 1990s, when this low fat diet was being advertised, right, for cardiac health, that unfortunately, there wasn't a very good messaging on what should replace the fat. And so, unfortunately, this led to a huge boom in the food industry of simple carbohydrates and sugar added foods. And so what we know is that if fat is substituted with simple carbohydrates, like sugar sweetened cereals, we actually get an increased risk of metabolic disease, and that's not good. So there's a diet known as the Therapeutic lifestyle change diet, and that pulls 25 to 35% of total calories from fat. And they further break it down to 10% of these should come from polyunsaturated fatty acids, 20% of these should come from monounsaturated fatty acids, such as avocados or olives, and saturated fats should remain less than 7% of total daily calories. 50 to 60% of the total calories can come from carbohydrates. Again, if this is a 2,000 calorie diet, that can actually mean that you can get anywhere up to 250 to even 300 grams of carbohydrate daily on something like a therapeutic lifestyle change diet. Soluble fiber is talked about 5 to 10 grams per day at least, which is truthfully quite low. 10 to 25 grams per day better, 40 grams per day even better, and 2 grams per day of plant sterols. Another diet that some of you may have heard of in the restricted fat variant category is the Ornish diet. I'm not going to go into it in detail, but you see it listed here. I will mention, though, that Dr. Dean Ornish is one of these physicians that is really one of the trailblazers of lifestyle medicine. And he's been practicing this since the 1980s and 1990s and really trying to prevent and reverse disease. Then we have the whole food plant-based diet. So what is it? Well, whole foods. Whole foods are natural foods that are not heavily processed. They're unrefined or minimally refined ingredients. Plant-based is pretty self-explanatory. Those are foods that come from plants. And so in this type of a diet, it encourages you to avoid animal ingredients such as meats, milk, eggs, or honey. And so in a food plant-based diet, besides the obvious fruits and veggies, tubers, so sweet potatoes, carrots, beets, whole grains, quinoa, millet, farro, and legumes, lentils, kidney beans, and chickpeas all compose this type of plant-based diet. Sometimes questions come up, is plant-based the same thing as vegan? And so if you really dilute it down, the answer is no, not necessarily. And there's also even a distinction between plant-based and whole food plant-based. And I found that this table from the Forks Over Knives website does a good job of sort of differentiating between them. And truthfully, a lot of people might even sort of float between these different columns. But as you can see here in a strict vegan diet, there's absolutely no animal source. Whereas in a plant-based or a whole food plant-based, technically it says to avoid animal sources. Now, individuals can adopt that and say, actually no animal source for me in a whole food plant-based. But the recommendation is avoiding. In a vegan diet and plant-based diet, you can see oils are okay to use, whereas in a whole food plant-based diet, it's actually recommended to avoid oils. And highly processed foods can sneak their way into vegan diets, potentially into plant-based diets. Whereas again, in a whole food plant-based diet, you're advocating for the food in its natural form, and so want to avoid highly processed foods. The whole grains, the fruit veggies, starchy veggies, and legumes are things that each three of these different nutrition approaches all agree on. So I included this graph because I find it really interesting. So I'm going to walk you guys through it because I know it looks like there's a lot going on, and there is a lot going on. But basically what this graph is showing is the amount of processed foods, whether it's less processed, moderately, or highly processed foods that a household brought into their home, and how much each of those different levels of processing exceeded the nutrition recommendations for different nutrition components. Okay, so here on the y-axis, we have from 0 to 100%, it's the percent exceeding a recommendation. Here on the x-axis, we have saturated fat. So the recommendation is no more than 10% of your calories per day should come from saturated fat. Here in this cluster, we have total sugar. No more than 15% of your calories should come from total sugar in a day. And in this last cluster, in this cluster, we have sodium. So the recommendation is less than 2,400. And so this was in 2012. So if we look at this first one, looking at for the foods that are less processed, what percentage of those foods exceeded the recommendation of saturated fats? About 30%. Contrast this to the highly processed food, where almost 95% of highly processed food exceeded the recommendation of saturated fat. And this percentage was pretty similar if you were looking at total sugar and looking at sodium content. And then in this very last cluster, if you put them all together, if you put exceeded saturated fat recommendation, total sugar recommendation, sodium recommendation, the highly processed foods exceeded those recommendations of all three 60% of the time, compared to just 5.6% of less processed food. And so I think this is a very stark representation of how highly processed food, such as what we find in the standard American diet, can often lead to excess of unhealthy nutritive components. Okay, so how can we reduce or reverse disease? So this is just a gentle reminder, and hashtag harsh truths. Unfortunately, excuses don't burn calories. Take my word for it, I've tried, doesn't work. So I'm going to propose to you that it's time to be inefficient, okay? And maybe some of you are like, what are you talking about? Because especially in today's world, right, where we have so many professional obligations, so many personal obligations, so many virtual obligations, we're just being pulled from all these different directions. And we have all these tasks to complete in a day. And so the only way we can do it is to multitask. So humans have become geniuses at multitasking, granted some better than others, but we've adapted, right? We've become efficient in the tasks that we need to do. And this efficiency is important because it saves time and it saves energy, which is great, which is fantastic. And it is great and fantastic for that. But when it comes to trying to enhance metabolism, trying to enhance our energy expenditure, we need to try to find a way to be inefficient with our exercise, inefficient with our food absorption in safe ways, so that we can increase our energy expenditure. And I'll get to how to do that. So I'm going to bring back this slide that I discussed earlier on in the talk, right? Where we defined metabolism, how our body makes and releases energy based on what we eat and what we drink. And remember, this is total energy expenditure. And it's made up of three components: resting energy expenditure. How can we activate it? Well, there are certain components which we can't control, which are just static. So in the resting energy expenditure, okay, body size and composition, individuals with obesity, individuals with more muscle mass, they burn more calories at rest. Sex is also a determinant of resting energy expenditure. Men tend to have less percent body fat, tend to have more muscle mass than women at any given age. And so they also tend to burn more calories than women. Age is also an important determinant of resting energy expenditure. As we get older, our lean body mass tends to decrease, the percent fat mass tends to increase, and this results in reduced energy expenditure. And sleep. Sleep is so important. Sleep, honestly, is its whole other talk, but I just wanted to mention how important sleep is also to our resting energy expenditure. If we don't get enough sleep, if we don't get enough good quality sleep, this will also result in decreased energy expenditure. And the most recent data we have suggests that really the sweet spot for adults is trying to get between 7.5 and 8.5 hours of sleep per night. Okay, so resting energy expenditure is one of those that's more static. So where do we have some opportunity to increase our energy expenditure? Well, non-resting energy expenditure makes up 30 to 40% of our total. So how can we get it closer to the 40%? So this is through physical activity, all right? This is intentional exercise, like running, like walking, like cycling, like weightlifting, all right? But here, this is where we want to try to be inefficient. What do I mean by that? I don't want you to do anything that's high risk or that you're going to injure yourself with. But what you want to do is try to choose exercises that are varied, that don't work the same muscle group over and over and over again. Because why? Our bodies are super smart. If we engage in the same type of activity over and over and over again, this learned behavior our body adapts to. It becomes efficient. And so when we engage in that activity, we no longer burn the same amount of calories that we did when we initiated the activity in the first place. And so by changing it up, feeling sore each time you do something different, that's a way that we prevent our muscles from adapting, increasing energy expenditure. But intentional exercise isn't the whole picture in this non-resting energy expenditure. There's something called NEAT, and this acronym stands for non-exercise activity thermogenesis. So what is NEAT? NEAT is non-deliberate exercise. This is when you go outside and garden, or if you're storing stuff in the garage, if you're walking from the car to the store, if you're talking with your hands, if you're fidgeting. So these are all unintentional movements, or non-intentional exercise movements, but movements nonetheless that expend energy. And what studies have shown is that this non-exercise activity thermogenesis can account from anywhere to 150 to an extra 700 calories per day burned. And also, there's some thought behind that those individuals who are thought to be naturally skinny, which sure, there certainly is genetic component to body composition. But if you think of somebody that you're like, oh, they're just naturally skinny, there might also be, when you think about it, maybe they're more kinetic. Maybe they move around a lot. They can never sit still. These are these people that are constantly having to do something. And so they're expending more energy through this NEAT activity. And then the third component, right? The thermogenic effect of food. So that can comprise anywhere between 5 to 10% of our total energy expenditure. So how can we try to push it to closer to 10%? And so fiber-rich foods is one way we can do so. So thermogenic effect of food, again, that's the amount of energy that our body needs to digest, to absorb food, transport food, etc. And so our bodies have to work more for foods that are high in protein and high in fiber. Both of these increase the thermogenic effect of food. And so foods that are high in fiber, plant-based foods, it's the cellulose. The cellulose is this plant carbohydrate that human bodies are incapable of digesting. So in order to get to the good stuff, our bodies have to work harder to break down the cellulose. This increases the thermogenic effect of food. Well, why is that even important? Well, again, if we're trying to expend calories and reduce how many calories we're absorbing, if you look at, for example, 100 calories of sugar cookies, all 100, because of how processed it is, will be absorbed. It's easily absorbed. Contrast that to 100 calories of almonds. Well, actually only 7 kilocalories of those are absorbed, okay? And so you can extend this even further. Instead of perhaps white rice, which is more refined and easier to absorb, perhaps you would consider using lentils or even brown rice. Again, higher fiber content. Okay, so let's talk about different types of nutrition plans, right? We hear a lot about, and people, right, feel very passionate. Low-fat diet is the way to go. Low-carb diet is the way to go. So which one is it, right? Is there one that's better than the other? And so there's been thoughts that by choosing a low-fat diet, such as a plant-based diet, which focuses on higher carb and low fat because we're eliminating animal sources, that's not conducive to weight loss because there's higher insulin levels that are associated with it, and that is counterproductive for weight loss. And then the low carb diet, the ketogenic diet, that also has gained a lot of traction for a very quick way to lose weight. But some might say, you know what, you're also eating a higher density of food. that promotes weight gain. So in 2018, Dr. Gardner, who is a researcher at Stanford, published a study called Diet Fits. And some of you, many of you are probably very familiar with this study. But just to review, this was a really fascinating study. And so there had been also some suspicion that genetic predispositions of individuals might make them more susceptible to lose weight if they have a genetic predisposition for a low carb diet, if they actually followed a low carb diet. And the same was true if they had a genetic predisposition for a low fat diet, they probably would lose more weight in a low fat diet. And so they did some tests looking at these polymorphisms, but essentially they gathered 600 individuals, okay, adults. None of them had diabetes, and their BMI range was between 28 and 40. And they randomized them, okay, to two groups. One was the healthy low carb group, and the other one was the healthy low fat group. What does that mean? So they were discouraged from consuming ultra processed foods, discouraged from sugar sweetened beverages. They were given classes on healthy eating in the group that they were randomized to. And they were followed for 12 months. And what did they find at the end of this 12-month study? What they found that the amount of weight loss in the low carb group was no different than the amount of weight loss in the low fat group. Both groups lost just over 11 pounds over a 12-month study period. And what this graph shows is actually the amount of weight loss per each participant. On the top, we see the low fat group, and on the bottom, we see the low carb group. And what I think you guys can just eyeball and appreciate is that these graphs look very similar. We had some responders that lost a lot of weight, and there were even some individuals who gained weight during this trial. And another conclusion was that they did not see that certain genetic predispositions, even if they were randomized to the group that fit their genetic predisposition, resulted in more weight loss. So that was really interesting. Another study I wanted to share with you, it was actually just published 3 weeks ago, and I found this to be really interesting. And so this was performed by Dr. Hall and his group at the National Institutes of Health. So they were looking at the effect of a plant-based low-fat diet versus an animal-based ketogenic diet on ad libitum energy intake. So let me explain what they did here. So it was a small study. They took 20 individuals, and none of them had diabetes. And so what they did was that they admitted them to the National Institutes of Health laboratories, and they stayed there for 28 days. And these individuals were randomized to two groups. So the first group, for the first 2 weeks, would receive low carb. So that was the ketogenic diet for 2 whole weeks, and then immediately were transitioned to a plant-based low fat diet. Whereas the other group was just flipped. They started with a plant-based diet for 2 weeks and then immediately switched to a ketogenic diet for the last 2 weeks. All the meals were prepared there at the NIH, and they were allowed to eat as much as they wanted to. There was no calorie restriction. They said, and they even told the participants, listen, this is not a weight loss trial. You're free to eat however much you want, whenever you want. And so the goal of this study was really to determine whether having free access to high carb or high fat diets resulted in greater calorie intake. And so what they found is shown here in this graph. So when the individuals were on a low carb diet, okay, so this is the ketogenic diet, they ate more calories during that 2-week period. Contrasted to when they were on the plant-based diet, they ate fewer calories. And as you can see, truly in the ketogenic diet, low carb, which is in green, high fat. Plant-based diet, high carb, low fat, okay? There's another graphic that I didn't put in here that shows that actually they reported the same satisfaction, the same enjoyment of the low carb diet and the low fat diet. This is another graph that essentially shows, once again, that those individuals who were on the ketogenic diet, which is this red line, consumed more calories over the 14 days than those individuals than when they were on the low-fat diet. So each participant had an opportunity to be on both the low-fat and the low-carb diet. And the reason why they had lower calories on the low-fat or plant-based diet was not related to the fact that they didn't enjoy the food, because again, they enjoyed both diets the same. And so they looked at other secondary things. One was body weight change over the 2 weeks. And so what you can see here is when they were on the ketogenic diet, there was a rapid decline in weight in the first week, which seemed to stabilize in the second week, okay? Contrast that to the plant-based diet, those individuals lost weight too, but not as rapidly. And in fact, here at the 14-day mark, they saw that both the low-carb and the low-fat diet lost weight. And this difference in weight was actually not statistically significant between the two groups. But then they looked and said, okay, well, where is this weight loss coming from? And so what this graph is looking at is fat-free mass change. This is talking about like lean body mass, which is what we don't want to lose when we lose weight. And what you can see here is that those individuals who are on the ketogenic diet actually lost a significant amount of fat-free mass in this 2-week trial. Granted, it was only 2 weeks. Whereas those on the plant-based diet maintained their fat-free mass. When they looked at fat mass change, what they found was that those who were on the plant-based diet lost more fat mass over those 2 weeks versus those who were on the ketogenic animal-based diet. And so, you know, their conclusion was there was a higher amount of calorie intake when individuals were on the ketogenic diet. Both groups showed weight loss. And in this 2-week trial, those who were on the plant-based diet had more of a reduction in fat mass. Okay, so we know that now, with some of those studies that I just showed, that a plant-based diet is capable in assisting individuals in losing weight. So how does a plant-based nutrition program help with diabetes management? Well, Dr. Bernard in 2006 published a study where they took 99 individuals, and 49 were randomized to a vegan diet, and the other 50 were randomized to the American Diabetes Association diet recommendations that were given at that time in 2003. And basically, it was looking at their body composition, looking at their cholesterol profile, coming up with a nutrition plan with a certain calorie limit, whereas the vegan diet did not have a calorie limit. And it was a 22-week intervention. So these individuals, at the beginning of the study, here comes the A1C number again. Remember I said 7% is usually where we try to target to minimize complications. And so at the beginning of the study, on average, they were about 8%, so higher than this goal target. And over the 22 weeks, you can see here that this gray line, which is the vegan diet, decreased their A1C to 6.8% at the end of the 22-week trial. The ADA diet also had a reduction in their A1C, but it was more dramatic in the group that was randomized to the vegan diet. These individuals did not have their meals prepared for them. These were free living. Those who had been randomized to the vegan diet, almost 50% of those individuals were able to reduce their diabetes medications. Whereas those who were randomized to the American Diabetes Association diet, only 23% of them reduced their medications. And other studies have shown also that the more you add plants to your diet, the lower your risk of diabetes. And so if we take this here, this non-vegetarian group, and assume this number 1 is highest prevalence, as the number decreases, that denotes a reduction in diabetes risk. And so also as we come down, you can see that here we're adding more plants to the nutrition plan with a reduction in risk of diabetes prevalence. So how does plant-based diet improve diabetes? Well, certainly weight loss has a huge component, okay? Because with weight loss, we get a reduction of fat mass, we get improvement in insulin sensitivity. But is it all just because of the weight loss? So this was a really interesting study, and granted, it was several years ago, but they took 20 men with type 2 diabetes, all on insulin therapy. And they placed them on a high fiber diet, 65 grams of fiber per day. And it was a plant-based diet aimed for weight neutrality. They gave them enough calories to make sure they didn't lose weight, and they didn't. Nonetheless, over 16 days, 11 of the 20 men were able to discontinue their insulin therapy, and 9 of the 20 men were able to reduce their insulin doses. And so this showed that diabetes improved despite no change in their weight. So what are some other mechanisms that help individuals improve their diabetes on a plant-based diet? Well, on a plant-based diet, you get a reduction in saturated fat intake. And how is that helpful? Well, that can also help this intramyocellular lipid content. What is that? It's basically the amount of fat that's within muscle cells. And so if we can reduce fat droplets in cells, we can reduce insulin resistance, because now the muscle is more primed to respond to the insulin that's circulating in the body, which helps regulate blood sugar. And finally, another way is through increased dietary fiber intake. So fiber comes from vegetables, fruits, whole grains, and fiber has a prebiotic effect. What does that mean? So prebiotic effect means that it's the nutrition that's given to the healthy gut microbes. And Dr. Gentili gave a great talk about gut health last month. And basically, we're learning a whole lot more about how important our microbiome is for our health. And it's important to have healthy gut bacteria to ensure proper absorption of nutrients. With the fiber, remember I had mentioned how the cellulose is the plant starch that we cannot absorb. And so that's going to slow glucose absorption. Remember, inefficiency. And by slowing this glucose absorption, we get reduced blood sugar. This helps with our body's ability to process the sugar that is absorbed. And the fiber, as we talked about before too, will help with weight regulation. So this is the last study slide I will throw at you guys, but this was a meta-analysis just published last year. And they took only high quality studies looking at plant-based nutrition and diabetes risk. And so they took 9 of these largest studies and compiled all the information. And by taking those studies, it included over 300,000 participants. And basically what this graph is looking at is the risk, the relative risk of type 2 diabetes, okay? One being the highest risk and then going down. Here on the x-axis is this plant-based diet index. And essentially what this is referring to is the higher the number, the more plant-based it is. And so, as you can see, the more plant-based it is, this relative risk of type 2 diabetes also falls. So studies have shown that those individuals who are vegan have a low prevalence of diabetes. It's estimated to be less than 2.9%. Sweet, Oreos are vegan. Remember, it's the quality also, okay? Processed vegan diet, that actually leads to an increased risk of diabetes. So when it's coming from added sugars, simple carbohydrates, that can increase diabetes risk. And so here's this diabetes care journal that we use, and we get every year updates in the standards of care. And there is a nutrition section in our standards of care of diabetes. And what it says essentially is that no diet reigns supreme, that there is evidence showing that a variety of dietary approaches helps with diabetes. But I want to draw your attention here where it says evidence suggests that the overall quality of food consumed, with an emphasis on whole grains, legumes, nuts, fruits, and vegetables, and minimal refined and processed foods, is also associated with a lower risk of type 2 diabetes. And all of that should sound very familiar, right? What we've been discussing which you find a lot in a plant-based nutrition approach. And I also want to bring it back to the present time because, you know, we're all living in the time of COVID. This is why we're doing this through Zoom. And as an endocrinologist that also rounds in the hospital and takes care of patients in the hospital setting, we know that individuals with uncontrolled diabetes, individuals with obesity are particularly susceptible to adverse health outcomes if they contract COVID-19. And so anything that we can do to try to improve diabetes management, improve risk or decrease, right, the risk of developing obesity are things that we should try to do to also ensure that individuals aren't increasing their risk of any other potential adverse health pandemics that might come our way. So I just wanted to reiterate what my objectives were. Look at the time. I'm so sorry, I did speak for a long time. Thank you very much for your attention. And I don't know if we've just gone over, but if there is some time, I'm happy to answer some questions. Thank you once again.
Well, thank you, Dr. Sobel. It was fascinating. Thank you. Thank you. Some of you, one person said, I've got to leave. I understand it. We'll take, a few moments here and ask questions. As I said earlier, you will get the recording if you have to leave. So
I have a question.
Yes.
Okay. So you had mentioned and thank you for the presentation. It was incredibly informative. So thank you. You had mentioned in your presentation that visceral fat is the most troubling of all fat. And I saw some presentation by Dr. Michael Greger, who said people who tend to be apple-shaped, even if they lose weight and get down to that normal BMI through a whole food plant-based lifestyle, that they should try to get to the bottom end of that BMI range because of the visceral fat that they're likely carrying. Can you talk a little bit about that and explain that a little bit? Thank you.
Yeah, sure. Thank you very much for the question. So I think what Dr. Greger highlights is just the complexity of how we measure and how we quantify this dysfunctional fat. Because as I mentioned, BMI is just a number, right? And truthfully, it's also specific to even certain areas of the world, right? This BMI, normal BMI that we consider here in the United States of 18 to 25 is fine and normally good for us here, but we know also in the Asian population that actually 25 is considered overweight. And so what is it? Well, it's the differences are where this dysfunctional fat is located. And so the BMI is really all it does is it takes your weight and your height, but in no way is it telling you what your fat mass is. It's not telling you what your muscle mass is. It's not telling you where this fat is distributed, right? And so that's why it's complicated just using BMI. And so what Dr. Greger is talking about, if you're more apple-shaped, then that does suggest that it's more of a visceral component as opposed to pear-shaped, where it's probably more subcutaneous in the lower extremities and doesn't have that same metabolic risk. And so there are several different ways of assessing body composition or fat mass. And so that would be the best way to see, are you really making a dent in your weight loss efforts in reducing the visceral fat, is using measures that aren't BMI, because that will not tell you. So looking more at like measures such as DEXA. So DEXA is not only for bones, but is one way that we can also look at fat mass. There's the bod pod, there's underwater weight. So there are different ways of assessing fat mass. DEXA is probably one of the more easier ones, but it's hard to just use the BMI. It's super convenient, it's super easy to do, but dysfunctional fat characterization is much more complex than just the BMI.
Thank you.
Any other questions?
I have a question. I have a question.
Yes, Scott? Yes.
So what I haven't heard talked about is that there's a spectrum within plant-based eating. For example, some people say that fat itself produces insulin resistance, and you need to keep your fats, even healthy fats like nuts and avocados, total fat less than 15%. On the other end of the spectrum, there's a cardiologist I know who uses markers of inflammation, not just CRP, but other more advanced ones, and he recommends a lower carb plant-based diet, and meaning more avocado, nuts, seeds, olives or olive oil. Any comment about that spectrum?
Sure. And so, I mean, there is so much, right? I just scratched the surface on different types of nutrition approaches. And at the risk of holding you guys here for another hour, you know, going into the depths of the nuances between the diets would take more time. But to your point, the truth is there's a lot of medical literature that can support different types of nutrition, right? And so basically it's also whatever you believe in, that's the study you might go with, right? But to the point is, so for example, Dr. Esselstyn, right? And so I'm sure you're aware of his research and what he's done. And so he's very much whole food, plant-based, no oil, no avocado, right? And what he's published is quite remarkable, right? He's had these individuals with coronary artery disease have regression of their coronary plaques. And these were individuals who were deemed unfit for any type of intervention, right? And whereas other individuals, you know, avocados have oils in their diet, they're plant-based as well, and they also have low coronary risk profiles. So I think also there's a part of it, I mean, right, our bodies are so complex. And so there's a part of it is, what are we bringing to the table at the very beginning, right? What has already existed, what already exists in our biome before we choose a certain nutrition plan, because that also might determine how we respond. I haven't seen, and nor do I ever really think there will be one diet that reigns supreme.
Thanks.
That makes lots of sense. Anybody else?
I have a question. This is Katie, and I'm from South Carolina, and I have a question for you regarding fruits and diabetes and smoothies that you use fruits in. And I think there's some controversy about being able to eat fruits as the whole with the skin and the fiber that you get from the whole fruit. But can you address the impact, or do you support having smoothies? Or what impact does that have on the insulin resistance or the diabetes?
Sure, no, thank you for that question. And so the studies that look at plant-based nutrition, so higher carb diets that are healthy, higher carb diets, when they measure in glucose levels, will show that insulin levels are higher, and there could be higher glucose levels also immediately after the meal as compared to a high fat diet, like a keto diet, okay? But also the studies I showed that in the long term, people still see improvement of their diabetes because of reduction of fat mass, reduction of muscular fat, improvement of insulin sensitivity. So specifically, so fruit isn't the problem in diabetes, right? People, you know, got to diabetes and then they are high in carbohydrates, they are high in natural sugars. And so maybe if someone has really, really high blood sugars, initially we might say, let's just cool it a little bit on the fruits. Let's go more for the whole, you know, the vegetables and so forth. But eventually, once we get some more glycemic control, I mean, fruit's not the enemy, right? But there is something to be said that the fiber that comes in the peel of the apple, of whatever fruit it is, that's what's helping reduce that quick absorption of the fructose, which essentially can lead to higher blood sugars. And so to answer your question, I mean, smoothies, fine. You know, just don't put, I wouldn't advocate putting juice in it and using it, you know, not on a daily basis, but whenever you want to as an option, sure. As long as you have, you know, healthy other things that go in there. And then on the other days, you can take your apple and a handful of almonds, and that can be your breakfast, right?
Thank you. Thank you.
Anybody else? We'll take time for one more question if there is another question. And otherwise, wow. Thank you, Dr. Sobel. This was fantastic. And I'm going to send you the remarks that people in the chat room are putting to you or giving you about your presentations. You'll get all this feedback when I send you an email.
Thank you, everybody. Sorry, I can get carried away, but I really appreciate your attention.
You know, that's because you have the passion, and that's what we like. The knowledge and the passion. And we want physicians with that combination. Thank you again.
Thank you, everybody. Have a good night.